All right, so are we good to go? Cool, so good afternoon, everyone. Welcome to my talk, Take a Bite Out of the Logs with LogShark. My name is Dan Rom, and I'm an engagement engineer on our release and feedback team. So before I go through and start talking about LogShark, what it is and how we use it, I'd like to just quickly jump into the actual agenda itself. So within this presentation, we're going to talk about log analysis as we know it. So how do we go through and how do we analyze logs without the use of LogShark? After that, I'm going to go and dive into LogShark itself. So what is it? Why do we use it? How does it actually work? And once we kind of know a little bit more about LogShark, we'll just briefly jump into what it takes to go and build views with log data. Once that's all done, we'll just briefly touch on how to get involved with this project, and that should be it. So without further ado, I'll just begin. So when I was first building this presentation, I wanted to go through and I wanted to talk about how I go through and how I approach logs and how I view logs right now. And what I found is I started making lists, and all my lists were just terrible things about logs and why logs aren't fun to deal with. And I found that it wasn't constructive, but it also didn't get a message across of what can be done with logs. So what I found is a more constructive and easier way for me to express how we go through and how we actually work with logs now is just go through and actually talk about a couple of cases and a couple of examples of me working with logs and how my mind works and how I actually leverage the logs to do my own job. So let's jump into the first case. So the first case here is during a load test, all processes show down in the status page. So that means that we go and look at the status page and everything's red. Now, when I would go through, if I was only given the logs and what's sitting on my Windows machine, what I'd actually do is I'd go through and I'd first analyze the Tableau server process logs. So I'd go look into VizPortal, VizQL server, Apache, any of these major log files, because I'd want to see, are we actually getting crash processes? Are things still up and running? Because the status page shows things are down, but clearly we're getting some sort of activity. So I'd really want to know what's going on. So I'd start digging down into those. I'd look for any errors of crashing processes, any fatal errors, anything at all like that. I'd then also go and just look for general process activity. So if you go and you see that the status page shows something down, but you still see movement and activity within the logs, it's a pretty good indication that we never got a crash. Nothing's down. So something else beyond this is going down. Moving forward, I'd also go and I'd start analyzing the Apache logs. I'd take a look at what's in there. And the main reason I would want to do this is because I'd want to validate the load test. It's already stated that we're going through and we're hitting our Tableau server instance with a load test, and things just aren't working the way we'd expect it to. So really what I'd want to do is I'd want to confirm that, is my load test what I expect it to be? Is this the right number of threads, the right number of users? Am I loading the right views? I'd also just do things like look at the bootstrap times. If we see really high bootstrap times, maybe that's an indication that server actually fell over, that things are running really slow. But it's also a good indication that we're kind of stepping our way through and stepping up into the actual load test. The last thing I do, given just the Windows machine and everything that I have there, I would just go through and look for contextual indications that there is actually a crash. So I'd go and I'd look into the Windows event logs, look for dump files and app data, anything like that. So without any visualization at all, this is how I do it. And it's kind of hard and it's kind of bulky and it takes a long time. My second example is high resource usage is causing performance issues in Tableau server. Yet again, given only a Windows machine with logs, the first thing I'd do is I'd figure out where the high resource usage happened. Now, we don't have a time limit up here. We don't have anything that indicates as to when it happened. We just know it did happen. So what I would actually do is I'd go and I'd look in the logs and I'd look for things like SRM warnings, high resource usage. We log all this information out, and there's a wealth of it, but we'd have to go through and we'd have to use something like grep or just manually look through all of our logs until we find these. After that, we watch to see high resource usage patterns and maybe the task manager, maybe perfmon, tabmon, zabbix, whatever we have. We just go through and we try to use the tools that we have to really see if there is actually high resource usage. Moving forward, we'd go through, check the Windows event logs, because it will log out errors there if something's going on. And we might get some contextual information as to when we were seeing that high resource usage so that we can go through and start investigating it. Once I have all that done, yet again, I'd look at Apache. I just want to know what's going on in there. Are we actually going through and seeing activity? Are things crashing? Any sort of indication that a crash could really go through and affect our performance. So all of this, like I said, would take time, and I'd have to go through and we'd have to manually walk through and look at the crashes. So now we went through kind of a brief overview of the cases and the examples I wanted to talk about. Let's just talk about the common trends. So the real big one here is that everything I do is manual. Every time I look into a log file, I'm going through and have to know exactly what's going on, where it's going. I have to crack open the log files, I have to walk through it, and I really have to understand what's going on that server. That just means that I need a deep understanding, and sometimes that's not always available, and it takes a long time to go and hone the skills to know how everything's connected to each other, where you find certain session IDs, where you don't find those, and how it all plays into one whole product. So sometimes that's almost impossible to do. The next bit is it's really impossible to do aggregate analysis. So if there was any sort of pattern there, so say on Tuesdays we get really long load times, I wouldn't see that. Would I know if the issue's inconsistent or consistent? Maybe not, because maybe the issue only goes through and happens, once or twice a day. Maybe the load times are spiking sometimes and loading fast other times. So there's a lot of things that you can go through and you can read in the logs that don't necessarily make sense, that you can't necessarily put numbers to. So if you wanted to know the average load time for a view within a certain day, there's really no way to do that. The last bit is there's not always exact timestamps when we go through and we do our investigations. The reason I bring this up is because this is one of the biggest challenges to work around when we're going through and we're actually doing our troubleshooting. How do I know what's going on in my environment when it's going on in my environment? If someone tells you, between the hours of 4 and 6, I hit this one error, how are you going to go through and find that one error within those 2 hours? You're going to spend time and you're going to look and look and look, and eventually you're going to find it. So it's slow, it's bulky, and sometimes all the data you need isn't quite there. So now that I kind of described my life without LogShark and how I go through and I walk through the logs just at a super high level, let's go through and let's talk about LogShark a little bit. Sorry about that. So to start off with, I'm going to just talk about what is LogShark. LogShark is an open source tool that parses Tableau server logs and stores these out in Mongo. We take the resulting data set, we run a series of ETL solutions on them in the form of plugins, and we store these out to Postgres as a Tableau-friendly data source. That way we can go through and we can actually pull these into workbooks and build views off of them. So essentially what we're doing is we're just taking your logs, pulling them apart, and putting them in Postgres so we can go through and we can actually build views that tell us about what's going on within your server deployments, within desktop, what have you. Now that we know what it is, I just want to go through and I want to step out and I just want to show you guys how the install works. Before I do that, let's talk about the requirements. So we need to have a 64-bit Windows operating system. We need .NET Framework 4.5.1, Tableau Desktop 9.3 or later. And this is actually for the workbooks we export, nothing else. We don't leverage anything else there. MongoDB, this is actually included in the LogShark installation, but it's always nice to have your own Mongo database so you can go through and you can persist your data for as long as you'd like. And the last bit is an actual Postgres database. That way you can go through and you can actually store the output of the ETL solutions. So let me jump out real quick and we'll go through and we'll take a look. So to actually go through and install LogShark, it's fairly simple. All we have to do is we go through and we grab the installer here. It's just a simple executable written in Windows Installer XML framework, so Wix. We go and we hit run, and this is what pops up. So really what it is it just shows you where it's installing, and it just gives you a warning that, this can go through and can use a lot of resources. We can need a lot of disk space, so just make sure that when you install this, you're well aware that you're going through and what you're installing is pretty hefty. Just to jump down to the options real quick, it's pretty lightweight here. All we're doing is we're just allowing you to specify a path, as well as we're allowing you to put LogShark within the path automatically. So when you pull open the CLI, you can just type LogShark whatever, as opposed to going to the actual directory. And then we allow you to go through and create a menu shortcut. So let's say OK, and let's just do an install. And so we'll watch that go through, and that's it. That's all it takes. Now, all we really need to do to run LogShark is just go through, open a command window. Actually, did I get that? Oh, no, I didn't. OK. I'm sorry about that. That's my bad. And we just type LogShark, and then the actual directory that we're working with. So C, users, DROM, desktop, and then logs. And so all I'd have to do here, just hit enter. It'll go through, it'll do the extraction process, push everything into Mongo, and then it'll run whatever plugins that we have existing in the plugins folder. Now we do have an ability to go through and specify things like the database name that we're gonna write to, as well as the actual plugins we're gonna run, but at the core, that's all that's gonna happen. Now, I'm not actually gonna run this in front of you guys because it's kind of a long, slow process. Yeah, of course.
So this is an output file?
No, so this is actually just the logs that we're gonna run. The output file will be found in the actual LogShark directory, and there's an output folder.
So where did you get the zip file?
The zip file is just a log file. It's an example log file that I have, yeah. And so like I said, I'm not necessarily gonna run that now. It's not exactly interesting to go through and see, but that's honestly how easy it is to set up LogShark. So once we have LogShark set up, let's go and jump back in. So now that we have LogShark set up, let's go through and let's talk about why LogShark. One, I wanted to go through and talk about why LogShark and why I think it's worth talking about and worth using. I decided that the best way to do this would actually be to go through and revisit those cases that I talked about earlier, and instead apply LogShark to it and show what exactly LogShark's doing for me and doing for everyone here. So let's go through and let's do a recap of case one. So case one is during a load test, all processes are down in the status page. Now, initially, we went through and we could go through and look at all the logs. We could go and look at the Apache logs, the Viz portal logs, the VizQL server logs. We could go and spend hours there. But instead, the way we'd approach it with LogShark is we'd first go and look at the Apache report. And the reason I say the Apache report is because the Apache report is really the gateway to our server system. It allows us to see at a very high level what's going on within Tableau server and what kind of requests we're actually getting. Within that report, I really am honestly looking for spikes in numbers of requests, and as well as binning the number of requests by minute, because I want to see how the actual request number increases, because in this case, we're doing a load test. We need to make sure that everything is consistent and we have a fairly linear increase in the actual load on our server. Once I'm done with that, I'd go through and I'd actually look at the VizQL report. Now, this isn't as important because all I'm doing here is I'm just looking for fatal errors. I'm looking for anything that shows that we might be down, just making sure that we aren't actually down. Now that we have the high level, let's go through and let's jump into a few screenshots I actually took of what happened and what I saw when I started looking into LogShark. So the first thing we can see up there is we can actually go and see the start of that load test. And as you see, most of the request times are fairly even keel. It doesn't take that long. But right at about 8 or so, I think that's 8, you'll go and you see this increase in the actual time it takes to go through and complete your requests to load your views, up until the point when you actually, up here, hit timeouts. And that means that we took over half an hour to go and try to load a view, we timed out, and we're gonna get an error. So already we can see something's kind of funky here because we go from fairly even keel, everything's looking good, to a massive spike in actual load. Now, if we go through and look at the bottom is exactly what I was talking about when I said we'll bin the number of requests by minute. So what I did there is I actually said, minute by minute, how many loads are we actually trying to do? And you can see that it's pretty much linear all the way up until we hit about here. Once we hit there, you get a 20 to 30% rise on the number of bootstraps per minute. So what that indicates to me is, maybe we just designed our load test wrong. Maybe we went through and instead of going and being linear the whole way through, we did something weird and all of a sudden we're getting an exponential increase. So in the actual case when this happened, I went through and I started talking to the team and I said, hey guys, why did we go through and why did we put an exponential increase in the number of bootstraps, 10 minutes in? And the answer was, well, we didn't. Nothing happened there. This was supposed to go through and increase at a linear rate until either it passed or Tableau server fell over. So knowing that, I went back and I took a look at the logs again. And so I knew that what we were doing is we were actually increasing users and increasing the amount of views that we had per user. So I ended up making another graph that's a Gantt chart of all the requests sent by users as we go through and add users to this load test. And here we can see it's linear. We are going through and we are starting users and we're staggering them, and we actually have a consistent gap between the requests we're sitting there. Now, all of this holds true until we hit here, this giant red line, this giant angry red line. So seeing that, the first question I had is, well, why is there a giant red line there? Why are we all of a sudden seeing 10 times the number of requests per minute as we were before? So I started looking at everything that's green there, and I realized there's one key to this. Every single one of those green requests took under 30 seconds. It took under 30 seconds for those to go through and return. Everything in red there took above 30 seconds. So knowing this, I went back and talked to the team. I said, hey guys, I found this really, really weird pattern. Anything over 30 seconds is actually going through, and once we hit there, we're just going through and running tons and tons of requests. So we're going through and exponentially increasing the number of requests. When I said that, it immediately sparked someone who had written the test goes, oh, I put a retry in that. So after 30 seconds of going through and waiting for a request to return, if I don't hear a response, I retry and I send it again. So really what happened here is using LogShark, we were able to go through and find the patterns to ask the questions to see that there was in fact an issue with the load test we were running, and that by doing this, we were actually going through and we were running out of ephemeral ports, which showed everything down. So this allowed us to go through and see the patterns, go and talk and ask the questions and work with the team to really say, oh, what's going on here? Why do we see this? So just to the conclusion there, as I said, it allowed us to ask the questions. We were able to work with the team. We were able to go through and increase the ephemeral ports. We were also able to go through and turn off the retry. And because of that pattern spotting abilities that LogShark allowed us, we were able to go through and spot the issue. Now, let's go through and talk a little bit about how LogShark actually helped us. So the first thing is it allowed us to narrow down the load test time frame. That's huge in these situations. Like I said, if you have hours and hours of data to look at, knowing exactly when things happened is half the battle. Once we saw that, we were able to show the requests per minute. We were able to show the increase in requests per minute, and we're able to reveal that at 30 seconds we had that retry. So now that we've done case one, let's go through and revisit case two. Case two is high resource usage is causing performance issues in Tableau server. Initially, when I'd go through and I'd approach this, I'd first look at our SRM workbook. The reason I would look at our SRM report is because it will give us a good idea as to the resources we're using. SRM stands for Server Resource Manager, so periodically it'll log out the actual resources that each process is consuming. Within this report, I'd look for high resource usage, whether it's CPU or memory. I'd look for it through processes. And I just want to know, generally, are we actually seeing that performance issue? Once I'm done with that, yet again, step back to Apache, get that 10,000-foot view, and I'd look for a large number of requests. I'd go through and I'd see maybe we're just hitting the server too hard. Maybe we loaded too many views at one time, and all of a sudden we're running out of resources and things are crashing and nothing's fun. Once we're done with that, I'd also look into maybe this is due to a single workbook. Maybe we're going through and loading one workbook and it's just eating all of the resources we have. But I'd also just go through and look for general patterns, and that's really what this is about. It's about going through and understanding the patterns and being able to do some sort of aggregate analysis on this. Instead of going through and looking at screenshots, though, I think it'd be nice to do a demo, go and step into how I actually apply this. So I actually have the data for both the resource monitor and the Apache workbook. So let's crack that open. So here, we can actually see the resource usage from Tableau server. So over here, this is going to be our CPU usage, and that's going to be our memory utilization. Here we can see that actually CPU utilization, it's pretty low, nothing to worry about. But this is where this gets a little bit more fun. This is our memory usage, and this is the increase over time. And we see it increases and drops and increases and drops. Immediately when I see that, the first thing I start to think of is memory leak. That's the only thing that will really drive memory at a consistent rate like that and cause processes to drop off. So I'm already thinking this could totally be a memory leak. Once I know that, I'm not really going to go through and dig into the CPU anymore because I can see that the CPU usage isn't really that high. So we'll go through and we'll actually dig into the memory usage by process. And yet again, we can go and look and we can see, hey, that's still the increase that we were looking at, and that increase is still steady, and it's all done by VizQL server. So what this tells me is that we are constantly using memory within VizQL server, and we're never releasing it. And when we do release it, it looks like we're basically crashing the process. So knowing this, let's go and step into the Apache workbook. Let's go and see how that can help us out. We already have some clues from context, so let's go through and let's try to finish this off. All right, so the first thing we do when we pull up in the Apache workbook is we notice something's a little bit odd here. Now, the reason I say that is because this right here is supposed to be the top workbooks loaded. That means that the top 10, 20, however many workbooks you have specified there will show up. That only shows one workbook, and it was only loaded 7 times. The question starts to come here, maybe it's just one really bad workbook. Maybe we loaded those workbooks 7 times, and that kind of caused the issue. Unlikely, because, well, we would probably see that beforehand. But overall, nothing too serious. We also see that there is a pretty low load time for this. If this was going to be really resource intensive, generally we'd see this spike, and it would be huge. But on average, it's less than half a second. So knowing this and kind of seeing this, I want to go a little bit more granular with this. I want to go and step and look at the actual request itself. So we pull open to the granular load statistics, and we can see that, yet again, seven loads. They're all scattered throughout the day, and they're not really clumped that close together. So it doesn't really make sense that this would actually just be a single load or a couple loads of a workbook that go through and exhaust memory. Now, knowing this, my next thought would be, let's dig into this data, let's go through, let's ask our questions. So because I assume that this isn't actually an issue with the load itself, I decided I'm going to go through and I'm going to go and turn off the filter. So I'm going to, instead of just showing the workbook loads, I'm going to show all the requests that aren't workbook loads, see what's going on within Tableau server and how it works. So we click OK here, and all of a sudden, we start to see patterns emerge. Yet again, we see this clear line right here of the same request over and over and over again. If we pull that open a little bit more, and we'll actually just do this using the show data button. So let's go and show our backend data. Right there. And then we can actually scroll down, and we can see that what we're hitting is the refresh data server command twice every 2 seconds. That means we're sitting there and we're refreshing data over and over and over and over again. To me, this is kind of the last snail. I understand exactly what's going on now. So the issue is we have a workbook that sits up on a monitor, and we go through and we try to refresh the data every 2 seconds. And the reason we do this is because we want to see the newest data every single time we go and look at that workbook. So going back to that, when I actually did the investigation, what we ended up doing is we went through and we nailed down the repro. We saw that what was going on, we saw the exact command that was going on, how to do that command. So we repro'd the issue, we took a memory dump at the top and at the bottom, and you know what? In the end, we were actually able to go through and spot a memory leak. The nice thing about this is those patterns wouldn't have emerged if we just looked at logs. We would go through and we'd get some outsourced resource usage, some outside memory resource monitor, something like Zabbix, something like SolarWinds. And we'd go and we'd take a look at that, and hopefully we'd start to get the clues, but I don't think we'd necessarily spot that the data server refresh was there. So knowing that, we were actually able to go through, pinpoint that, nail down our repro, and we fixed that. And that's actually in your product now. That code that fixed that was spotted by LogShark, now exists within Tableau Desktop and Tableau Server right now. So yet again, how did LogShark help us? Well, LogShark, yet again, allowed us to efficiently nail down the time frame of what's going on. It showed us what processes use the resources, what the patterns were, and just the general workbook loads that we were seeing. Overall, it took the time it takes us to spot these errors, to go through and read and pull this apart, and it cut it in half. This was easily a case that could have taken 20 to 30 hours, but because we were able to spot this, in this room together, it took us 5 minutes. So, moving on, let's go through and let's just briefly do an overhead again. So why LogShark? Ease of use. It's a CLI. All we have to do is just give it a set of logs, and we just run the CLI, and we just let it sit. And it'll go through, and it'll run, it'll parse it, it'll run the ETL solutions. Everything is done automatically for you. Next is that we have fairly efficient log storage now. Initially, without this, what you'd end up doing is you'd go and you'd collect your zip logs, and you'd put them on a hard drive somewhere, and they'd sit there. With LogShark, as long as Mongo is set up on its own, you can go through and you can parse all your logs, and you keep your logs in Mongo, so you can have historical logs for however long you want to keep them. Next bit is we're able to persist that data. So we're able to go through, we're able to run these ETL solutions, build these data sources, and persist them. That means we're able to go through and we're able to look at the historical data of what's going on throughout time. So it's optional to install Mongo, but if you don't install Mongo on your own, you can't persist the data within Mongo because we basically spin up Mongo briefly for the parsing, then we run that. There's two of the guys back there who wrote the core, and so we'll have them talk about that afterwards if you're curious. But the other bit that helped us is it allowed us to structure our logs. And a lot of times you go through, you read logs, they're very human readable, but they're not machine readable. There's no structure to them. They seem arbitrary. By going through and running these through the plugins, we were able to go through, put structure to them, and consume them using Tableau. And the last bit is we were able to use aggregate analysis. We were able to go through and spot patterns, go and look at the logs. And so instead of reading them, we're really going and asking our questions about our data and exploring our data. So now that we understand LogShark a little bit and how we use it, why I really like it, let's just briefly look at how LogShark works. So the first phase in LogShark is the initialization phase. We basically go through, pull open the log file, we create a hash for it, and so that's actually the target hash we're going to use. Once we do that, we do a hash generation and check. So we create the hash based off the contents. We check it against Mongo if Mongo is up and running. That way, if it is up and running, we go through and we skip the processing stage. If not, we go through and continue the processing stage and store it in Mongo with that hash value. Once that's done, and as long as we don't get a matching hash within Mongo, we'll go through and we'll start the extraction process. For zipped files, that means we actually go through and we unzip them. And we do this in parallel for anything that's nested. For anything that's a target directory, we just move it over to the temp folder and run everything off of that. Once that's done, we go to pre-processing. That means that any of the larger files that we have, we'll go through and we'll split them down to what we think is an acceptable interval to go through and actually increase the storage time. Once we're done with that, we go to processing, and processing by far is the longest piece of running LogShark. That means we're going through, we're taking every single log event, we are parsing it and creating a BSON document and storing that off of Mongo. Once we're done with that, we load the plugins, we execute the plugins, and then we clean up. And that's pretty much all it takes. Once we get done with that cleanup process, we're free to go and look at the workbooks, and we're free to explore our own data because it already exists in Postgres. So with that, that's LogShark in a nutshell and kind of how it works. But I didn't want to just focus on only LogShark and why I like LogShark. I also kind of wanted to step into just a brief analysis of, how do we go through and how do we build views with log data? Because it's nice to have data, but going through and actually building a view with your data is half the challenge. So to start this off, I just want to talk a little bit about Tableau Server's architecture. The reason I want to talk about this is because understanding LogShark and the joins you can do and what data sources work well with others really comes down to understanding Tableau Server's architecture. So at its core, Tableau Server is a distributed web application. That means every single process is its own free-form, free-floating process, and they all have a different function. Tasks, for the most part, are routed transparently, which means that you can go through and you can see request IDs, or you can see request IDs that correspond to separate logs. We can go and we can scrape Apache to see any requests that are sent back and forth, but overall, it's transparent. Down here, we see a little bit about Tableau Server and its basic architecture. So everything starts at the gateway, like I said, that's the Apache server. Then we go into the core components, which are the application server, the VizQL server, data server. So that's anything needed to go through and actually render the page you're looking at, render the view you're looking at, authentication, and data server. And for the most part, all of these right here will have an ID. So they'll have a request ID that's sent up from Apache, and so you're able to go through and join that way. Once we have that, we have several different connectors. We have our SQL connector, our MDX connectors, and our data engine. Now, it's a bit harder to go through and actually step into these connectors and do the log visualization, so we don't really have to worry about that too much. But the other piece here that we can actually look at is we can go and parse and look at our repository logs. So if we want to know what's going on within Postgres itself, you can go and actually build views off of it. So moving on, I just want to talk about how the logs are actually structured a little bit, because this also kind of describes how we go through and how we do our parsing and how we start visualizations. So each component has its own log set. That's pretty much the core essence of it. So if you go and you look over here at the actual folder structure, you can see that most major components will actually have their own folder, and within their folder, they'll have the corresponding logs. All of these logs are placed at the root of the zip logs, and the actual workers are going to be nested within that log folder as well. If we dive into those worker folders, you'll actually see the exact same structure, but they won't have workers embedded in them. So we know about the logs. We know how they all kind of work together. Let's just go through and talk about log formats, because this is the next big piece in understanding how we go through and how we visualize. So we really have two forms of logs and then one bucket that I call miscellaneous. So the Java logs are things like the viz portal logs, the server logs, background logs. They're really anything at our application layer, the top layer of everything. So if you go through and you start looking into the Java logs, you're going to see very high-level process actions. And so you'll see things like running this schedule or loading this view, authenticating this user, but you don't necessarily see the nitty-gritty of everything. The next type of logs we have are actually the C++ or the DLL logs. Examples of these are VizQL server, viz portal backgrounder. This is really where all the magic happens. This is the core frame set of actual Tableau server. And this is where you can see things like workbook loads, schedules being built, people being authenticated. So this is really where it all happens. After that, we have things that are called the miscellaneous logs. We have lots and lots of different programs that aren't ours. And so we'll actually go through and we'll log out using native formats. So things like the Apache logs, for instance, is going to log out in the Apache native format. But we still go through and we still parse these and we still put these into LogShark. Now that we know that, let's just go and talk about general tips for building these views. So the first thing that I'd like to talk about is aggregation. Going through and just looking at raw data from what I've discussed, it's hard. It's hard to see patterns. We go through and we tend to see too much. And so by going through and generalizing and aggregating our data, finding the mins, the maxes, the averages, we can go through and we can explore patterns. We can see what's going on at a bit of a larger scale, a higher scale here. The next tip is time scaling. Pretty much everything that we looked at today was set to a time scale. So it's the requests per time, the number of users by time, how long the requests actually took. And so we were actually able to go through and kind of analyze what's going on in Tableau server in a real-time-esque fashion by going through and placing everything to a time scale. The next thing is understand how the logs are connected. This is, like I said, the hard part. And this isn't necessarily something that I can teach all of you, not in at least an hour. It'd take a lot longer than that. But by going through and practicing and watching these and walking through these, looking at the Tableau server architecture, asking questions, looking at the different IDs we have, the sessions IDs, the request IDs, we can understand how the logs are connected. The reason this is huge is because this allows us to build our joins. It allows us to combine data. Yeah?
Is there some sort of data dictionary that would, understood, you can't sit down with each one of us in 1 hour, but if you take 10 hours and write the documentation, 100 people can read it.
I'm not sure if there is one, but if you come back to me, we can maybe look for it, because I'm not 100% sure if there's a data dictionary out there right now. And if there is, I'm not sure if it'd be up to date, because we change things pretty quickly. But yeah, so the last tip I have is experiment. I can only tell you guys so much about how I go through and I build these views and how I use these views, but really it comes down to your guys' questions. The magical part about Tableau Desktop is the fact that we allow you to go and see and understand your data, ask your questions, and really start digging. If everyone went through and just did the average of everything over time, we'd all be asking the same question. And I think that kind of misses the point of actually going through and using LogShark and visualizing our data. So with that being said, I just want to talk a little bit about LogShark and how to get involved. LogShark can be found on GitHub. Currently, it's on release 1.0. There's also a user guide up here, just in case you guys want to go to that. It tells you a little bit more about the requirements of LogShark, a little bit into how it works, what we need to install, some installer guides, and maybe a little bit of like some fact tables, so you can go through and you can look at some frequently asked questions, and hopefully that answers some questions. If not, there is actually a forum there, so we can go through and we can go and create issues or ask questions on that. So hopefully at the end of the session, you guys all have a better idea of what it was like to go through and analyze logs. Can I get to you as soon as, yeah. Sweet, awesome. So hopefully you guys have a better idea as to what it was like to go through and do analysis without logs, or with logs without LogShark, and then sort of stepped into why we would use this, why we would even want to go through and visualize our logs, why we would want to make these data sources. And hopefully we all have a better idea of how we can actually go through and build the views. So if anyone has any questions, feel free to ask. If not, have a great day. So there was one guy in the very back, and then I'll get to you. Yes, yep. Oh, wait. Let me repeat the question again. So the question was that the logs that we actually show in the LogShark command that I wrote, if those are the logs that we just get from zip logs. So the answer to that is yes. But I think there's another question?
Yeah. So if you're troubleshooting like a one-off server message, like all these Internet Explorer messages, like syntax error or anything,
Yeah.
can you use this to troubleshoot things like those?
So the question is, if we go through and we have things like Internet Explorer errors, can we go through and use the tool to go through and troubleshoot it? So any sort of Tableau errors. So yeah, any sort of Tableau errors can actually be used, can actually be analyzed with this. The VizQL workbook has a really nice view in it called the error workbook. It shows any single error that we found within the actual C++ logs. It's a good way to get a high level down. It may not necessarily answer all the questions, but hopefully by going through and looking at it, you should be able to go through and understand the time frame of things and understand what part of the logs you need to look into. Because when I go through and I use LogShark, I'm not necessarily looking at it to answer to tell me what's wrong exactly, but I use it as a tool to go through and increase the performance and increase my efficiency when I'm going and pulling things apart. So did that answer your question?
Sure. And if I have a batch of that runs every night, extract the logs,
Yeah.
the process to get any
Yes, you can. So the question is, can you keep them in the MongoDB forever? So natively, yes. You would keep them in Mongo forever. You can go and build a purging service, or you can delete them whenever you want. We don't really write anything that has interactions with Mongo, really, other than inserting and querying. So we won't go through and we won't actually purge data out of Mongo. So I'm going to answer your question, right? Yep, and then I'll move over here.
So when you created the views, what did you connect Tableau Desktop to? Did you go through Postgres?
Yes, so it was just a direct Postgres connection. This, for the actual demo though, I went through and I extracted all the data because I really figured you guys didn't want to wait for my queries to run, so everything's extracted here.
What's the, when you connect to Postgres, there's like common tables, right? What's the table?
So for the Apache workbook, there's only one. It's the Apache report table. I think that's what it's called. It'll actually go through, and when it outputs the workbooks, it'll pull out the connection string and replace it, so it'll automatically connect to your database, by the way. So you don't necessarily need to know that. But I think it's called like the Apache report table. I'll have to look into exactly what it's called again. I'm a bit rusty on that. But anything else? So, OK, cool. I'll get you up front, and then you and back after that. Cool. OK, so the question is, how do I get my logs into the Mongo database? That's actually done directly through the CLI. So when we go through and you say LogShark ziplogs.zip, it will go through and it starts extracting and parsing, and it will go through and use a series of regex parsers as well as a JSON parser to go through and build the BSON documents that we then persist up to Mongo. Yeah, so the question is, if you had a series of logs, could you make it continuous? So the answer to that is yes. So basically the way we would do that is you'd go through and you'd take zip logs every single day or whatever your frequency is, and then you would actually push them up using LogShark, except for you'd use the tag --db name, and you'd specify a name for a persisted table. And so otherwise what we do is we're going to go through and build a table that's based off of the hash that we generate for the logs that you're working with. So by going through and specifying the actual DB name that you're working with, you can go through and you can persist your data out. Should be. I think so, yep. Justin's shaking his head, so that's a yes. Cool. So, yep. Yeah, of course.
What
Okay, so the question is, what are the log levels we use and whether it matters? So I think we're pretty much agnostic about log level. I think they're Justin, Mike actually might.
So we assume that you're normally going to be running this with info level logging. And I'm assuming a lot of people don't like to run debug level logging for long term. And so by default, we only target info level. However, there is a flag that you can supply on the command line to enable the processing of debug level logs.
Yeah.
Turn that on, it's going to take significantly longer because you're going to have an order of magnitude more lines to go through.
Cool.
Second one was, do you recommend a second machine?
Okay, so the second question is, do we recommend a second machine? Yes. Definitely recommend running this on your own machine. Most of this is multi-threaded. It can be kind of harsh, so I would definitely put it off on its own. You can go and write, if you have a pre-existing Postgres instance, that's not the Tableau server Postgres instance. Please never write into the Tableau Postgres instance. That's just no. But if you have your own sitting there and you have your own Mongo instance, feel free to use those. It may need a little bit of configuration as far as the user permissions go, but overall it should work. Yeah, I think there was one more question back there, and then I'll jump there and there. So yeah, so I got.
How do you compare LogShark to Splunk if you have the option of using either?
Okay, so how would I compare LogShark to Splunk? What I find with Splunk is that I have a lot of it seems to be kind of bulk inserts, so it just takes my log line and kind of throws it in there and pulls some metadata off of it and allows me to go through and query based off of my metadata. So I can go through and look at like request ID and that sort of stuff, the time it happened, but the actual metadata isn't persisted as its own object, so I can't go through and directly query it. When we go through and we actually use LogShark, everything is broken down into its own portion of the BSON document. So I can essentially go in there and say, all right, well, I would like to go through and I would like to query anything that has a session ID that's equal to this. And I find that in certain cases, it's a lot harder to do that with Splunk. But on the other hand, Splunk, I feel sometimes can go through and handle larger sets of data. So really, it's all about your use case. If I'm going to visualize something, I tend to go with LogShark just because right now, the ETL that we're actually doing on it just makes the data a lot more usable. Okay, so Mike.
Can I touch on that a little bit?
Yeah.
So a lot of the stuff that we're doing with plugins have to span multiple log lines. So we use things like, for instance, if you've ever looked at background logs, a single background job is going to span multiple lines. So in order to generate the entries in the Postgres database that encapsulate your information about a single background job, we actually need to do things in Mongo like query a range of log lines filtered by this particular thread ID based on this job ID, and then in our plugin framework, we actually collapse that down into sort of like a single object, and that's what ends up getting persisted. So it's a lot more than just sort of taking in things that can be presented on one line and keep them.
Cool. So I think we had you, and then I'll jump over to you guys, right? Cool. All right. So.
So is there a practical limit to the number of days of logs you should try to look at one time? So like if you go on your server and it's about 7 days, is that too much?
Okay, so the question is if there is a practical limit on how big the log files are and how long you should go back. The answer is kind of yes and no. So basically the way you think about it is the larger the log set, the longer it's going to take to run. So say you have a log set that you have 30 days worth of logs in and you're running on a massive system with thousands of people. That could take days to process just based off of the size. So if you want it to be small and performant, I would definitely go with smaller logs. Now, if we're going through and we're talking about persisting it out to the same database so we can go through and we can continuously look at the data, I don't necessarily think that we have a cap on what we can and can't use because really what we're doing is we're using it just like we'd use Postgres. So the answer the answer in question there is kind of, do we have a hard cap for how much data we can pull out of Postgres? And so If you go through and leverage indexing correctly and that sort of thing, depending on your usage, you might be able to go and look at a month's worth of logs. The queries may be slow, it may be difficult sometimes. Maybe you need to start leveraging, incremental extracts or something, but you could potentially go through and use a ton of data with this. All right, so over here. No. Yep.
First of all, fantastic job on presenting this, in the case studies and everything. Awesome. Second, great job on the team for building this, man. This is incredible. Now my stupid question. The workbooks that you showed, you built those, or do any workbooks come with LogShark when
Okay, yeah. So the question is if the workbooks that I showed just come with the product at hand, or if they're something I built on my own. So I'm going to split the answers between two cases. The first case I actually built using a really, really early version of the data we were getting. So all of that was kind of custom made by myself. But for the second case, I was actually just using stock workbooks. And so within the actual plugin model, for the most part, unless you define a plugin that doesn't have a workbook resource object, you generally need to go through and build a workbook, or at least include a workbook within the package itself, so that when the plugin executes, it can actually output the workbook. The nice thing about doing that is because there is a workbook basically for every plugin we run, we're able to go through and chop out that connection bit and replace it with a new database that we're connecting to. So you don't ever have to think about, oh, I just ran LogShark. I got to go and change the name of the database I'm connecting to get the freshest data. It'll automatically be there. Cool. So did I see one over there before, or is it just you two? Thank you. Okay. Wait. Not sure. Okay. I'll start over there. If I miss you, I'm sorry. I'll jump back. Okay, so I'll start in the back. Yep.
So for the workbooks that are part of LogShark, it sounds like a broken record. Are they documented so that we know what the different businesses are actually trying to show? Otherwise, it's kind of like playing Jeopardy. We have all the answers. We got to figure out the question.
All right. So the question is, do we have documentation on the workbooks that are included with LogShark? I'm not necessarily sure about that answer. Justin, do you have a?
Yeah, so in the user guide, which is the whole road, there's a table that shows which plugins map to which workbooks. Beyond that, we're trying to make the workbooks as self-documenting as possible. So a lot of the JSON and multiple captions kind of explain what the results do. We probably need to iterate a little more on that in the next release.
Cool. All right. So sounds good. I think you had a question as well, right? And then we'll jump over here. Oh, over here then? Did I see you raise your hand? Sorry. Okay. So I guess we're going this way.
So my question is more on the installation of best practices.
Of course.
Would I be, so right now, on a lot of the services, install a backend script that extracts all the logs and saves a
Mm-hmm.
period of time. Would it make sense to put LogShark onto the Tableau server so it stores in a Postgres database, kind of similar to where the admin views would be? Or should we do a utility server or just run it off the
So the question is actually with the install itself and whether or not you should go through and do the install parallel to Tableau server, or if you should go and put it on its own separate box. Personally, I think you should put it on its own separate box. It can be pretty resource intensive. It can take up a lot of disk space, so it can be kind of gnarly to run on the same box as Tableau server. One thing that you could do is you could actually go through and export all of your logs that you script out into some sort of network drive, and you could just go through and periodically scrape that network drive and consume those logs and run those logs via another script. So that's how I would probably tackle that. All right. Yep. So the question is, if you have Tabjolt, can you go through and put LogShark? All right, cool. So the question is, if we have Tabjolt and LogShark together, can we go through and can we use the same databases, or can we put them side by side? The short answer, for the most part, yes. I've done it before. I've written to the same database before. Now, if you're going through and using both of them very heavily, you may see some performance decreases. Some things may not really work out very well, but overall, I can't think of any restrictions that we'd have that would make it so they're not able to work with each other. All right. Any other? Did I see? All right. Yep.
With the zip logs, is there a way to do that on the hourly? I know I've seen zip logs where it can say, give me only 1 day, or give me everything from X, Y, Z day. Is there a way to say zip logs, give me everything for the last hour or two?
So the question is, zip logs, if there's a way to give me everything for the last hour or two. I don't think so at this point. That might be a good feature request, though, for the team. Right now, I think the interval that we have set for the actual tab-embedded zip logs command is down to the days. So I think that's pretty much where we're stuck right now.
So, see, putting something like this where we're dumping zip logs for the last hour automatically goes to our utility server. Utility server does this, loads it up into
Yeah.
Tableau, and then if we start having problems, we switch over to Tableau.
I don't know of a good solution. Maybe we'll talk about that afterwards and powwow with Mike and Justin and see if they have any ideas for that, because I'm not necessarily sure how I'd actually tackle that right now. I'd have to think about it a little bit. Cool. So any other questions? If not, well, I'd just like to say thank you for coming. Just show you guys some of the related sessions, just because we have the server admin like a pro, building a bridge between IT and business, and Tableau server capacity planning and performance. And feel free to go and fill out the survey for this session. It'd be nice to see some feedback. So thank you, everybody. Thanks for coming.